The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Alrighty, so I had a request from a student for some problems. So we're going to take a look. This is from 6.3 part 1 from yesterday. And we're going to start out with number 15. It says, factor the polynomial completely. If the expression is not factorable, using integers, enter prime. All right, and the polynomial is 4x squared minus 17x plus 15. Okay, so we have a trinomial. It's in standard form, descending powers of the variable x. There is no greatest common factor that we can take out, and the leading coefficient is not a 1. So we're going to use grouping. A is 4, B is negative 17, and C is 15, corresponding to the coefficients of the first, second, and third terms. The product, which is A times C, 15 times 4 is 60. The sum, which is B, is negative 17. Let's consider the signs. To get a positive product, we have to have two numbers that are both positive or both negative. But if they were both positive and we added them together, we couldn't get a negative sum. So we need two negative numbers, all right? So I'm going to start with negative 60 and negative 1. That would give me the correct product, but it wouldn't give me the correct sum because the sum would be negative 61. Because negative 60 is even, I could cut it in half and then double the negative 1, and I still have a product of 60, negative 30 times negative 2. Now the sum is negative 32. Still not correct, but we're getting closer, all right? Negative 30 is even, so I could cut it in half and consequently, let's try that, negative 15, and double the negative 2, and I get, let's see, a sum that is negative 19. Well, we're getting closer and closer, but haven't quite gotten there yet because I need to get to negative 17. Well, let's see, negative 15. I can't cut it in half, but I could take a 3 out, and that would make it a negative 5, and multiply by 3 a negative 12. Oh, and that's negative 17. So there's my two numbers, negative 5 and negative 12. So now I'm going to come back here and rewrite the original trinomial, splitting the middle term into two terms whose coefficients are these two numbers. Okay, any questions about what I've done so far? So now, factoring by grouping, the greatest common factor of the first two terms is x. The leftovers are 4x minus 5. So here the leftovers are 4x minus 5. And for this down here, to equal this up here, I need a minus 3. That gives me minus 12x plus 15. So now the greatest common factor is 4x minus 5, and the leftovers are x minus 3. And there's the answer. Okay. Any questions about that before we go on to the next example? All righty. Same section. This is number 17. It says factor. We have negative 2x y squared minus 4xy plus 16x. All right. So this is a trinomial. It's in standard form in terms of y. The first term has y squared, the second term has y, and the third term has no y at all. So it is in standard form. Let's see. Oh, there is a greatest common factor. We could take out a 2. We could take out an x. I'm going to take out a -2 because my leading term, the one that has the y squared, is negative. So my greatest common factor is going to be -2x. I'm going to have y squared plus 2y minus 8. Let's see if that's correct. That would give me -2xy squared minus 4xy plus, yeah, okay. So now what's left here, this actually takes us back to section 6.2, leading coefficient of a 1. So we'll split the y's up. We need a product that's -8 and a sum that's 2. And let's see, how about 4 and -2? That would have a product of -8 and a sum of 2. So plus 4 and minus 2, and there's our final answer. Any questions there before we go on to the last example? All righty. This is number 19. It says factor the polynomial completely if the expression is not factorable using integers. Enter prime. 6s to the 5th power minus 26s to the 4th power minus 20s to the 3rd power. This is a trinomial. It is in standard form, descending powers of s. Greatest common factor. We could take a 2 out of the 6, the 26, and the 20, and we can take an s cubed out of all the terms. So 2s cubed. Leftovers are 3s squared minus 13s minus 10. So now we have a trinomial that has a leading coefficient other than a 1. So A is 3, B is -13, and C is -10. The product is -30. The sum is -13. How about -15 and 2? -15 times 2 is -30. -15 plus 2 is -13. So I've got 2s cubed, 3s squared minus 15s plus 2s minus 10. Using grouping, 2s cubed. The greatest common factor of the first two terms is 3s. I have s minus 5 left over. So s minus 5 left over, a plus 2 right there. So my final answer, 2s cubed times s minus 5 times 3s plus 2. Okay. Any questions about that? All right. Well, those were all the questions that came in through email. Do any of you have any questions before we go on? If so, now is the time to speak.
I was wondering if we could do number 24.
Okay. Do you want to just tell me what it is?
Yeah, it is 20. Sorry. It's 25c cubed 25c squared d cubed minus 10c cubed d squared minus 35c to the 4th and d to the 4th.
So have I got that copied correctly? Leah?
Yes.
Okay.
Yes. Mm-hmm.
All right. So the question is it in standard form? Well, it really isn't in standard form in terms of C or D. Let's see. I'm going to go ahead and put it in standard form in terms of C. And I could have done it in terms of D, and I can go back and do it that way if you want. But if I put it in standard form in terms of C, I've got -35 c to the 4th d to the 4th minus 10c cubed d squared plus 25c squared d cubed. And the reason it's now in standard form in terms of c is because it's got c to the fourth, c to the third, c to the second. Okay. All right. Now, let's get rid of those. My leading term is negative, so I'm going to factor out a negative. I'm going to take out a negative 5. That'll come out of 35, 10, and 25. And I can take out a c squared and a d cubed. So that's my greatest common factor. So left over, I'm going to have 7c squared d plus 2. Oh, no, I've messed up. I just realized I can't take out a d cubed because I only have the lowest power of d is d squared. So let me double check here. Okay, I think I'm all right now. So 7c squared d squared plus 2c minus 5d. Okay, let's see. I just want to make sure I've got everything correct there. If I take out a 5, that's minus 35, c to the fourth, d to the fourth, minus 10, c cubed d squared, plus 25c. Okay, now, looking at what's inside the parentheses, I've got c squared d squared, okay? So it's like my variable would be sort of like cd, but because of what's over here, there's no way I'm going to be able to factor that any further, okay? So it's not prime, but this would be the final answer, I do believe. So put that in, Leah, and see if it works for you, okay?
Thank you. I got to that part, but I couldn't go any further, so that's why.
Yeah, and again, you don't want to call this prime because you did
Right.
factor something.
Right. Thank you.
Uh-huh. Okay, anybody else? Anything before we go on?
I have a question, if that's
Sure.
okay.
Yeah, what is it?
I actually have two, but I'll
That's fine.
okay.
Bring
The
them
first
on.
one is 22. It's x cubed minus x squared plus 8x minus 8.
Okay, and what does it say to do? Factor?
Oh, choose like the right method to factor.
Okay.
Yeah.
So there's 4 terms. What would the right method be? 4 terms. Factoring by grouping. Okay. Now, there's no greatest common factor for all 4 terms except a 1, and that doesn't do anything for us. So we're going to split it up into 2 groups of 2. The greatest common factor of the first 2 terms is x squared. Leftovers x minus 1. So my leftovers over here have to be x minus 1 and a plus 8 outside. So I get x minus 1, x squared plus 8, just like that. You all right with that one?
Yeah, thank you. I don't know why I was overthinking it.
It's okay. I was underthinking it. Okay. You had another one?
Yeah, if that's okay.
Yeah, that's why
number
we're here.
number 25. It's 9n to the power of 8
Okay.
minus 71n to the power of 7 minus 8n to the power of 6.
All right. Have I got that correct? 9, negative 71, negative 8.
Yes.
Okay, so there's nothing I can take out of the 9, the 7, the 71, and the 8, but I can take out an n to the 6th. So n to the 6th is going to be my greatest common factor, 9n squared minus 71n minus 8. Okay. So A is 9, B is negative 71, and C is negative 8. The product is negative 72. And the sum is negative 1. When we first started this problem and I saw that negative 71, I thought, oh, this is going to be horrible. No, it's not. It's going to be quite easy, in fact, because My two numbers are negative 72 and positive 1. I don't know why, but for some reason, these kind of problems, students overlook that they don't think about the possibility of a 1 as part of it. But do you see how that's got the product and the sum correctly there?
Yes.
Okay, excellent. So now I've got n to the 6th, 9n squared minus 72n plus 1n minus 8. Factoring by grouping, n to the 6th, greatest common factor 9n, n minus 8 left over, n minus 8 left over, plus 1 goes inside there, n to the 6th, n minus 8, 9n plus 1. And as I'm doing this, if I'm going too fast, if somebody's got a question, please stop me, interrupt me. I'm not here for my own amusement. Okay. You all right with that one, Juan?
Yes, thank you very much.
Yeah. Any others? You or anybody else? Okay, so what we're going to do today, we're going to stay in section 6.3, but I'm going to show you an alternative method of doing the problems, okay? And now, WebAssign, since you're just putting in the answer, WebAssign doesn't know which method you're using to solve it. But what I'd like you to do is I'd like you to use the method I'm going to show you today on tonight's assignment so that you get a taste of both methods. Then you can choose which method you prefer, and then from here on out, use that method. Or you may find that on some problems you use one and on some use the other. That's kind of where I'm at. This method we're going to use today, I use that when there's not a lot of possibilities, but if there's a lot of things to look at, then I use the other method, and we'll see how that goes. Okay. So let's start out with a trinomial, 3x squared plus 4x plus 1. Now, this method is called the, what is it? Check and, I can't never remember what they call this. Guess and check?
Trial and check.
Trial and check. Okay, yeah. Like I said, there's so many different names for it. So we start out the same. We have a trinomial. We have it in standard form. We take out any greatest common factor first. Since it doesn't have a leading coefficient of a 1, we're going to use this method, the trial and check method, okay? What we need to do first is we take the coefficient of the leading term, the 3, and we write all factor pairs whose product is 3. So basically 3 and 1, okay? Then we go to the last term and we write all the factor pairs of that number, which is basically just 1 and 1, okay? This is a fairly simple one. We'll look at some more complicated ones as we go. Now what I do is I form all the possible binomial pairs using one of these in front and the other in front, and one of these at the end and the other at the end. Now, this is x and this is x, and this is plus and this is plus. Now, because if I switch these around or if I switch these around, it doesn't change anything. Basically, this problem is done. Now, I didn't really get into all the complicated details because there wasn't a lot to do, but this is an excellent example of where it would be faster to do the problem this way than to use grouping. But now let's take a look at another problem. 15a squared minus 28a plus 5. Again, we have a trinomial. It's in standard form in terms of the variable a. There's no greatest common factor, and the leading coefficient is not a 1. The 15 on the front could be broken down into 15 times 1 and 5 times 3. Okay, those are the factor pairs that give me 15. The 5 at the end would be a 5 and a 1, except that our middle term is negative, so it's going to have to be a -5 and a -1. So now what I'm going to do is I'm going to create all of the factor pairs whose leading terms in each one is these numbers, and whose ending terms in each one is those numbers. I'm going to get rid of that A. So there's a possibility. But I could also have that possibility, switching those around. But I could also have this possibility, or that possibility. So I'm taking one of these and one of those, and then the other of these with the other of those, and then I'm switching them around. So I've got all the different possible combinations. So before I go on, do you see where I got all of those? Every one of those, if I multiply it back together, will give me 15a squared at the beginning and plus 5 at the end. But the correct one is the one that gives me negative 28a in the middle. So let's do the middle, which is the outer and the inner. 15a times negative 1 is negative 15a. Minus 5a would be negative 20a. So that one's not correct. 15a times minus 5 is minus 75a. Minus 1a is minus 76a. So that one's not correct. 5a times negative 1 is negative 5a. Minus 5 times 3a is minus 15a. Minus 5a plus minus 15a is minus 20a. That one's not correct. Some of you might think I deliberately made the last one the correct answer. I didn't deliberately do anything. I just wrote them all down. This is what? Negative 25a minus 3a. Bingo. There's the correct answer. When I FOIL it back together, I get 15a squared minus 25a minus 3a plus 5. 15a squared minus 28a plus 5. Okay. So let me pause and let you kind of take this in. Do you see what I did there? I laid out all the different combinations. There's the trial and check method. You're trying all these different combinations.
So for the combinations that you all tried, you just have to get when you FOIL it, it has to be the final product of 15a squared minus 28a plus 5.
Right. And by using these, your first and last terms are going to show up. It's the middle term you're looking for. Now,
Okay.
this method, if you can't do little multiplication stuff in your head, you're not going to like this method because it's a lot of writing. But if you can do the little multiplication stuff in your head, you'll probably prefer this one over the grouping method. And let me explain that. Okay, let me see here. Let's erase all of this. Let's start over. Might have been faster to just rewrite it on the next page, but I didn't feel like it. All right. So again, we're going to come up with the factor pairs. Okay. Now, how did I create these factor pairs? I took one of these with one of those, and the other of these with the other of those. Okay. If I multiplied that together, I get, let's see. Hang on a second. What did I say here? Actually, I took what? This times that would be negative 15. And this times that would be negative 5, right? What's negative 15 plus negative 5? What's negative 15 plus negative 5?
Negative 20.
Right. So here I'd have negative 15 plus negative 5 would be negative 20a. So that's not right. So then I'd switch them around and I'd say, okay, let's do the 15 with the -5, that's -75. And 1 times -1 is -1, and -75 plus -1 is -76. So this combination with this combination isn't going to work. So let's try this one. 5 times -5 is -25. 3 times -1. Again, I take one of these times one of those, and the other of these times the other of those. 5 times -5 is -25. 3 times -1 is -3. -25 plus -3 is -28. Bingo. So what that tells me is I've got to have the 5a and the 3a like I had here. I took the 5 times the -5, so that's got to go over here because I don't multiply these together. I multiplied those together. And I know this is still a bit confusing, but if you can crunch the numbers, so in other words, if you can quickly see that, okay, that's not going to work, that's not going to work, that's going to work, you can get there fairly quickly. Okay. If you can do that, you're going to love this one over the other method. But if you have to write them all out like I did the first example, you're going to be going, oh, this is awful. So again, it just kind of depends. Let's take a look at this one. 4b squared plus 15bc minus 4c squared. Okay. It's a trinomial in standard form in terms of b. There's no greatest common factor, and the leading coefficient is not a1. 4 is 4 times 1 or 2 times 2. -4 is -4 times 1, 4 times -1, or 2 times -2. Now I could also write -2 times 2, but that's the same thing, switching the two around. Okay. Now I'm looking for 15. I want to take a number from this group times a number from that group, and then take the other number in that pair times the other number in this pair and get 15. We'll take a look at this. 4 times 4 is 16, and 1 times -1 is -1. 16 plus -1 is 15. Bingo. So what does that mean? That means I've got 4b and 1b, and then a 4 and -1. If I put the 4 here, I'm not going to be multiplying it by the 4b. So I've got to have a 4 there and a -1 there. I'll get rid of this one. And there you go. Done. Now, I did that really quickly because I could look here. I had it on erase. Bummer. Sorry about that. Hang on. 4b squared plus 15bc minus 4c squared. Okay. Because I knew I was looking for a 15, and scanning these groups, I saw, oh, 4 times 4 is 16, 1 times -1, -15 total. Do you see that?
Where's the seed? Like, what happened to the seed?
Oh, good question. Where would the C have to be? I was so enthralled by how quickly I was going to do this, I messed up and left out the C. Good comment there. All right.
I have a question.
Absolutely.
So on the last one, you multiplied 15 times -1, but on this one you multiplied 4 times 4. Does it matter which if the first number multiplies the second number? If that makes sense, I don't know.
So you said here I did what? The
So
15
you multiplied the 5 with the -1, and on the next one you did 4 times 4. I don't know.
Well, okay. So let me see if I can get you to follow what I'm doing here. All right. So are you okay with where I got those groups of numbers?
Yeah, yeah.
What I have to do is take one of these times one of those. And the other of these times the other of those. Okay. And I try that. That's negative 16 plus 1 is negative 15. That didn't work. So now I come back and I take one of these times the other of those, and then those times that, and I try that. So I try one of these with one of those, and then I switch the order of these. So I'm trying all the different combinations.
Oh, yeah, that makes sense. Yeah.
But I don't literally have to try all the combinations if I can see. And again, it's how quickly you can do the little arithmetic. Because I'm looking at this and going, 4 times negative 4 is negative. Here, let's get rid of all that extra stuff again. If I go 4 times negative 4 is negative 16, 1 times 1 is 1, negative 16 plus 1 is negative 15, not going to work. Start over. I'm going to take 4 times, I did it again. I'm going to take 4 times 1, and then the 1 times the negative 4. 4 plus negative 4 is 0. That's not going to work. I take 4 times 4 is 16. 1 times negative 1 is negative 1. 16 plus negative 1 is 15. Bingo. But if it didn't work, then I'd go on and I'd take 4 times negative 1 and 1 times 4. So I'm trying all the different combinations without literally writing them all out like I had to do. Where did I think I erased it? Yeah, I erased all the, in other words, if you have to literally write out, maybe I should do that. Maybe that would help. Let me go back and do it the long way again to kind of see. Right, so given these combinations, these are the possibilities. 4B, 1B, negative 4C plus 1C. I don't need those ones. Okay. 4B, B plus C minus 4C. So what I just did was I took, let's see, this one times that one, and then this one times that one. I don't know if this is making sense or not. And then here I'd have, let's see, oh, I'd try 4B and B, and I'd try plus 4C minus 1C, and a 4B and a minus C, and a 4B and a plus 4C. That's taking these with all of these. Or I'd have a 4B and a B, and let's see here, a plus 2C and a minus 2C, or a 4B and a B, a minus 2C and a plus 2C. And then I've got all of these, 2B and 2B, and a minus 4C and a minus C. Now, because these are identical, switching them around wouldn't produce anything different. So I got a 2B and then a what? Plus 4C and a minus C. I don't know if, you know, it seems like kind of messy and kind of tedious. Can you tell that I'm not really crazy about this method?
Yes.
Most of my colleagues prefer it. And I think it's because if the expectations is that, well, at this level, you should be able to do all this little arithmetic in your head. I tend to take a more realistic approach and say, yeah, I think students are more comfortable writing stuff down than having to do all the little details in their head. But anyway, I'm gonna I'm going to abandon that one and I'm going to do a couple more here. Okay. 16r minus 40r squared plus 25r cubed. So the first thing I'm going to do is put this thing in standard form. Then I'm going to take out the greatest common factor, which is going to be just r, I think. Yeah. Okay. Now 25 is 25 and 1 or 5 and 5. 16, except it's got to be negative. So it's going to be negative 16 and negative 1, or negative 8 and negative 2, or negative 4 and negative 4. Okay.
A quick question, I'm sorry. Where did you get 25 again? Oh, okay, you just wrote it in standard form.
Yes. But see all the combinations I've got there? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different possibilities. Oh, wait, no, 6, 7, 8, 9 possibilities, since these two numbers are the same. So one possibility would be 25r. Now there's an r outside of all of these, right? The greatest common factor would be 25r and then 1r, and that corresponds to these two numbers. And then minus 16 minus 1 corresponds to those two numbers. Or I could have 25r and 1r, switching these two numbers around, minus 1 and minus 16. You see what I'm doing with all the combinations there?
Yeah, you're kind of doing like the commutative.
Kind of, but it's like these, I can take this number and put it first, or I can take this number and put it first. It's like, see, I don't know ahead of time which combination goes with which combination. So then I've got to try this one with this one. So then I've got 25r, r, minus 8, minus 2, or 25r, r, minus 2, minus 8. So I'm switching those around, but I'm still using the same two numbers.
Mm-hmm.
And then I've got 25r, r, and what? Minus 4 and minus 4. Since these two numbers are the same, switching them around wouldn't change anything. But so this gives me all the possibilities of this with all of these. But then I've got this one with all of those. So it could be 5r, minus 16 minus 1, 5r, minus 8 minus 2, 5r, minus 4 minus 4. Since these two numbers are the same, switching the 5r's around would still give me the same possibility. So there's 8 different possibilities. Which one is correct? The one that gives me minus 40r squared in the middle. So let's see, this is going to be minus 25, minus 16. Nope. That's going to be minus really big, minus 1. Nope. Minus 50, minus 8. Nope. Minus 200, minus 2. Nope. Minus 100, minus 4. Nope. Minus 5, minus 80. Nope, that's not going to do it. Let's see here. Minus 10, minus 40 is minus 50. Minus 20, minus 20. Bingo. And again, I didn't do this on purpose, but it was the very last one. That's the one that gave me negative 40r squared in the middle. This is where I wish you could see more than just my pen on the paper or the whiteboard. But how would I come up with that without doing all of these? Again, what I'd have to do is go through and say, where do I get negative 40? Oh, 5 times negative 4 is negative 20. 5 times negative 4 is negative 20. Negative 20 plus negative 20. Bingo. And there's my answer. If you can do this like I just did it, you're going to prefer this method over the other one. But if you have to write all of these out, you're going to prefer the other method. Okay. But I still want you to try this method, because usually in a class of 30, I have maybe 2, 3, or 4 students that like this method better. But for those 2, 3, or 4 students, you know, I need to show you this method. So, and maybe none of you will do that. Maybe you'll try this and you go, oh, this is awful. I want to do the other method. Either way, but try it to find out. Okay. One more example. Oops. Trinomial, standard form, no greatest common factor. Leading coefficient isn't a 1. So 10 and 1, 5 and 2. Over here, -6 and 1, -1 and 6, -2 and 3, -3 and 2. So the first column is going to be the coefficients of the variable terms. The second column is going to be the constant term. But I need -13. Can you see, looking at the groups without having to literally write it all out? And this is where, again, I wish you could see it. I could just use my fingers because I could say 10 times -6 is -60. 1 times 1 is 1. -60 plus 1 is not -13. Ten times 1, 1 times -6. 10 times 1 is 10. 1 times -6 is -6. 10 plus -6 is 4. It's not -13. So that means that this combination and this combination don't work. But I can't eliminate either one because this one over here still might work with one of these, and this one here might work with that. So there's a lot of trial and error going on. Let's try this one with this. 60, 1 times -1, -1, 60 plus -1 is -59. That didn't work. Okay. How about that? Oh, that's the same one I did before, isn't it? Let's see here. 10 times -1 and 1 times 6 is 60 minus 10 is 50. Anyway, not getting to -13. So where is -13 at? 30 minus 2, 50. Oh, Look here, that and that. 5 times -3 is -15. Nope, that's not going to do it. 10, -6. None of them are working. How fun was that? Now, to be convinced that this number is prime, I would have had to try 1, 2, 3, 4, 5, 6, 7, 8, 16 different combinations. This one, having done it this way, I'm thinking, oh, grouping method would have been so much easier for this problem, but I didn't, I'm supposed to be demonstrating this other method. But, well, I've probably confused the heck out of you, convinced you that you don't like this method, and you haven't even tried it yet. But you'll find, like I say, with the smaller numbered problems.
Mr. Mayo?
Yeah.
I'm sorry. The 5 times the -3 makes it -15, and then the 2 times 2 makes it +4. Doesn't that make it the -13?
Nope, that makes it -11.
Oh yeah. Okay, you're right.
It's okay. It's okay.
Thank you.
When I looked at it, I was thinking it was going to work, and then it's like, oh no, it doesn't. Yeah. So there's no combination there. Okay. So you got to really be careful if you're before you declare something prime, that you've tried all the combinations to see whether any of them are gonna work. Okay. So do you feel like I'm throwing you to the lions? Maybe a little bit. But again, let me go back to a simpler one. 2b squared plus 7b plus 3. Well, it's got to be a 2 and a 1 and a 3 and a 1. So it's either got to be this or that. So which one is it? It's that one, because there's your 7. 2 times 3 is 6, and 1 times 1 is 1, and 6 and 1 is 7. So this goes like this, and the 2 gets multiplied by the 3, which means it can't go there. It's got to go over here, because you don't multiply within the binomial. Is that making any sense? No one knows.
Yes.
Yeah. So again, something like this, it's fairly easy. It's quicker to use this method. But when there's a lot of combinations like this, then to me, it's awful. So realistically, if it was me, no one was watching, and I was given this problem, I would use the grouping method. If I was given this problem, I would just do the trial and check method. Okay. And I wouldn't even write, I just go, this has got to be that. And see, it's got to be a 3 and a 1. Well, where would I put the 3? Oh, there. And there's my 6 plus 1 is 7. Done. Okay. The more you practice, the better you get at it. All right. So tonight's assignment, I believe it's a shorter assignment. I can't remember for sure, but I want you to try this method. Okay. At least give it a try. I'll never know whether you do it or not, but it's for your own good to see if you like it, because some of you will decide, yeah, I like this method better. The rest of you will hate it, and that's fine. You'll figure that out. And then moving forward, you can use either method you want. Okay.
Okay.
All right. I'll be back at 1:15 if anybody has any questions. Otherwise, have a good day. Stay safe out there. Don't go anywhere if you don't have to.